welcome to March. How exciting. This month, our topic of conversation is looking at network bottlenecks, what they are, what they look like, everything to do with it. So I guess we should probably start exactly there and go, first of all, what are we talking about when we say a network bottleneck? What is it?
Great question, Paige. In the most simple terms, it's anything that stops network traffic flowing from point A to point B. Generally, you'll see that as slowness in an application across multiple people, or even a complete dropout that you can't get to a website, you can't send an email message. You may actually see it as streaming dropout on a video call or a Teams call or something like that, where you get freezing, you get breakup in audio, and that's going to be coming from some sort of network interruption most generally. And for a lot of organizations, that will actually start within their local area network. So that the network that's actually within their building before that even gets out onto the internet. So in a nutshell, a network bottleneck is anything that really slows down your network.
I mean, we've all experienced it. I mean, we'll probably experience it during this interview right now. So, aside from, things dropping out or the lags and buffering and all those, very frustrating experiences. From a technical perspective, is there something else that you look at it and go, oh, that's a bottleneck? Is there something that it looks like from a
Yeah,
technical
look,
perspective?
where it gets really interesting is networks per se are actually quite simple concepts. It's a piece of cable that goes from point A to point B. And from a logical perspective, that's exactly what it is. There's a piece of cable. Now, it can be physical cable, it can be wireless cable that connects your device to whatever the service is that you're actually using. Now, obviously, there's a lot more complexity in the background of that, but in a nutshell, that's what it looks like, is a single connection. Now, where it gets really, really tricky is that connection can have many other people and many other devices on it. So you can get what they call congestion or contention. And at scale, those sorts of things make a big difference in how you actually need to architect a network. And by architect a network, that means the order in which things are plugged together and perhaps even where they're plugged in, how many devices are connected, whether you need to have larger connections between certain classes of equipment, whether there's particular pieces of equipment that you need to put in there for security reasons or for review purposes and things like that. So it comes down to the whole question of it's not just the piece of cable, but it's the overall architecture, the specifications of equipment that are used to build out that architecture, and even down to the physical conditions that that equipment is housed in. All of these things can contribute to how effective, reliable, and resilient a network is in being able to avoid the bottlenecks that we quite often see.
Hmm. So that all sounds like a lot, right? But in terms of like how an organization, a business can prevent a bottleneck from occurring, say like it's someone's just starting up the business and it's quite small, or they haven't necessarily implemented a lot of their systems yet. What would that look like in terms of going, okay, what do I need to do to prevent this in the future when I haven't got anything, starting from scratch?
Yeah, look at this. This is where it can get quite tricky. So starting from scratch, if you're a solopreneur or a person working from home, is very different than if you're actually setting up, say, a manufacturing facility or a research facility. So while in a work from home or a solopreneur situation, you can get away with, say, an NBN connection and a router with Wi-Fi on it, and that'll work perfectly well for you on your own and maybe one or two colleagues in that situation. As soon as you start to scale that out to 5 or 6 people and a couple of devices each and things that are moving around, and a device that needs to do streaming and something that might be, you know, collecting CCTV footage and maybe some access control software and maybe a medical device that, is collecting telemetry data from patients, all of a sudden you've got a scale issue. And that's where you need to be very deliberate about understanding what it is you're trying to achieve and then actually working with people who can look at the technical requirements of each piece of equipment on its own, put all of those together in a meaningful way, and actually design an architecture and select the right equipment that's actually going to deliver the services so that nothing impacts, or none of the devices you're connecting impact on any of the other devices. And you're able to operate in a bottleneck free mode across all of the devices that are actually in place on the network. So for a startup's pretty easy. One device, really easy. As soon as you start to get to 20 to 30 to 40 devices, that gets tricky. As soon as you start to scale up to a couple of hundred devices, it becomes imperative that you actually have a defined architecture, that you actually know exactly what the specifications of each piece of equipment require, and how you actually deliver those, and how you actually connect everything together so that it actually works in a resilient manner, that somebody pulling a single cable out doesn't take the whole network down. So it's a progression, and the complexity really comes from scale.
Mm. So if you do have, quite a large organization, and you have, upwards of 40, 50, 100 devices, if, there's likely a lot of organizations out there who have been just putting out spot fires as they appear, there's a bottleneck, let's fix it as we go. Um, is that something that is not necessarily easy to fix, but is it, something that we can go, all right, where do we start and where do we go from there? What does that look like?
Look, the short answer is, of course. The longer answer is probably, um, how do you want to go about this? How important is your network? How many devices are there? And what do you actually know about your current network? We've had situations where we've literally walked into a facility where there's been several hundred devices, and nobody's even known the first thing of where the network equipment is located. So that becomes quite tricky in that you've actually got to go through what we call first principles, diagnose a network, find out where all the equipment is, trace everything out, and draw a picture. And then from that picture, you can start to put together whether that's an optimal design or whether it actually needs remediation, which is the term we often use. Then we put together an architecture, we work out what needs to change, we work out whether there's anything there that is not actually fit for purpose, and then we work out what the process is to actually fix everything up to a point where that network is solid, reliable, secure, and hopefully bottleneck free.
Yes. And so once we've got it to that point, is that full stop, case closed, we move on? Or is there
Oh, can I say I wish? The short answer is no. Look, the reality is networks are always changing and developing and growing, and the requirements placed on them are doing the same thing. So every time there's a new type of device come out, that needs to be reassessed to actually make sure that it will fit in with that network. So network technology in and of itself has changed enormously in the last 30 years that I can remember, and is getting smaller, cheaper, faster all the time. The other part of that is most network equipment is actually a powered electrical device, and they do wear out. So they're subject to the same environmental stresses and strains as any other type of electrical equipment, and even people on hot, muggy, humid days like today. So that equipment does wear out and does need to be replaced on a certain schedule. And a lot of times organizations will put networks in and treat them as a set and forget. And they're certainly not. They do have a life cycle. And as they start to get close to their end of life, they will start to have reliability issues. And that's where you can start to see random things like that device just restarted in the middle of the night and nobody actually knew about it. So management of life cycle is really important. The other part of that really comes down to how complex the network is oftentimes you'll actually want to know how much traffic is going across that network and how fast that traffic growth is happening. And remote monitoring and management becomes quite important so that you can actually assess capacity growth and whether there's actually requirements for change based on capacity utilization on a network. And again, that's not something that you want to wait until it's full. You want to actually know how fast it's filling up. So there's a couple of aspects there that, once a network is in place, it does actually require ongoing management, maintenance, and an understanding that it does actually have a finite life. And when you start to reach that end of life, concrete actions actually need to be taken to make sure that you don't have unexpected downtime.
Mm. So a mindset shift is needed. Sort of go, all right, we need to continually work on this. It's not, as you said, set to forget. We need to kind of
Yep.
constantly be working together to make sure that everything is working as well as it possibly can. Um,
Yeah, it's an understanding. It's networks, even though they're not seen, and for a lot of people, the network is the blue cable that hangs out of the wall, and there's not a lot of understanding of what else is behind that, and even down to the type of cabling. There's new cabling standards coming out all the time. There's also cable degrades. So, the old rat in the wall chewing on the cable has an impact on how reliable a network can be. So there needs to be a full understanding and appreciation that a network is an asset that degrades over time, and it needs to be maintained and managed accordingly. And not just, oh, we spent 10 grand on a network 5 years ago, and that's all we need to spend. It's a case of that's a depreciating asset. It needs to be managed as such, and understood that there comes a point in time when it's past end of life and will need to be replaced.
I mean, obviously, with all business and when there's money involved or time or effort, prioritization has to occur. What would you say, like, where do you think this should fit? I mean, depending obviously on the industry and the business itself, but why should they care? Why should they go, oh, I need to remember to do that for my network?
Perfect, perfect. Look, the reality around the why should you care is, I liken it to comparing a computer to a server, right? If you have a computer and it fails, one person's inconvenienced. If you have a server and it fails, multiple people are inconvenienced. If you have a network and it fails, everybody's inconvenienced. So network infrastructure, because of its multiplier effect of everybody connecting to it, becomes the single most critical piece of infrastructure, if you like, between the end consumer of services and the services that are being consumed. And if that network is not reliable, an hour of network downtime is the equivalent of perhaps 60 users being offline for an hour. So you've got 60 hours of downtime from 1 hour of network outage. So in terms of managing that risk, it needs to be understood that networks are more critical than just about anything else in a business technology environment. And if you don't pay them the level of respect, they will bite you.
Is there anything else that you think people should know or should be aware of in terms of their networks or working with a managed
Yeah,
provider?
the probably the biggest thing is to understand the difference in the quality of various types of equipment. So, while you can walk down to your local big box retail store and pick up a piece of network equipment for $100, that's a very, very different piece of equipment than what you will buy from a named manufacturer who specializes in that industry. So you will pay a premium for products like a Cisco or a Fortinet or Ruckus in that area. Those devices come with a price tag for a very good reason, and that is they'll have extended warranty. They'll have firmware maintenance lifespans of up to 10 years. They also have features that you won't find on what you buy at your local big box retail store for $100. So just be aware that yes, they are all pieces of network equipment, but there is a very, very large difference in the quality and capability of the two types of equipment. So what you would use in a home environment is very different to what you would use in a complex manufacturing or professional services environment. So it's very much horses for courses. And that's where your professional service advisor should be able to turn around and accurately understand your requirements and recommend the most appropriate piece of equipment, which may not be the cheapest. But believe their recommendation. If you need to ask questions as to why, you can always find an independent advisor who will be able to look at requirements and recommendation and give you a yay or nay as to whether that's appropriate.
Cool. And so if people have more questions or they want to do a little bit more research, is that something that they can find easily enough?
Absolutely. Absolutely. If you're not sure where to start, throw me a message on LinkedIn. Always happy to respond to that. There are some resource pages on our website, or failing that, there's some really, really good resources on some of the vendor pages. And if you're not sure which vendors are reputable and should be believed, just hit me up on LinkedIn and I'm happy to point you in the right direction.
Beautiful. Well, thank you for your time. I'll let you get back to it.
Thank you very much.